Okay, then save. Okay, have you done? One file is created, CFA fringe. Just click on CFA fringe, select here CFA fringe. Okay, go to the variable view, list of variable view, and the list of the items came. So go down, you will find CFA fringe fringe has 3 items, fringe 1, fringe 2, fringe 3. So we shall take this item, drag and drop here, fringe 1, fringe 2 and fringe 3. Yeah. Once you done, just close the list of variables. Okay, we have 4 blank indicators, right? We will delete all of this, take these erase objects and delete this. Okay, now it is deleted. Then click again, it will be deselected. Once you done, then double click on the latent variable to give the object name, variable name. If you double click there, in the text it is the variable name. You write here fringe, F-R-I-N-G-E, fringe. Then close it. Okay, have you done?
Yes.
Okay, so what will we do? We shall go to the plugins. Okay, then click on name unobserved variables. Okay, so error terms came. Your model is ready to run. So what will you do? Go to the calculate estimates. Okay, then click on calculate estimates. Everybody please. It is highlighted, right, in the right side, right button.
Yes.
Okay, just click on there. Your result is showing, it is unstandardized estimate. It is showing unstandardized estimate. See, 1.05 or like this. See, so click on standardized estimates. So the factor loading, and this is called the factor loading, the 0.76, 0.75, 0.81. So this is called factor loading. We denoted it as lambda value. What we call lambda value, and this is called the square. Lambda square. This is the value of lambda square. So this factor loading should not be less than 0.5, and it cannot be it cannot be 1. It should be less than 1. Okay, and the value of the factor loading cannot be negative. 3 criteria in the factor loading. Number 1, the values of factor loading cannot be negative, it cannot be less than 0.5, and it cannot be 1. It should be it must be less than 1. Okay, the factor loading. And here in the here, if we check in the this is called fit indexes. Here in the case of fringe, this chi-square should be less than actually the here we have some the chi-square value and chi-square differences is this one. So relative chi-square, this relative chi-square should be less than 5, and the chi-square should be 100 to 200, and the difference should be less whatever the difference is coming. If we divide the chi-square by the differences, this is called the relative chi-square, and these differences should not be more than 5, and this is the p value. This is significant p value. It should be less than 0.05, and GFI, AGFI, CFI, IFI, NFI, TLI. So all of these values should be more than 0.9, more than 0.9. In our case, all are showing 1. So that's mean is 100% okay. So that's why the result AGFI, CFI, IFI, NFI, TLI, it is not showing. And the Ramsey should be less than 0.08. Here in our case, in this particular fringe, it is 0.00. So that's why it is not showing. In other cases, it will show. I shall go through that one also. So as our model fit is 100% okay, and convergent validity is 100% okay. So we other decision criteria in other cases, in another CFA satisfaction, CFA performance, CFA welfare, there we will do it, inshallah, and we will show you if any complication comes in the model fit, how we have to resolve it. So just save it. Everybody please save it. Save the path diagram. Okay.
Yes, I have a question.
Yes, please.
So what happened to the wages, because that one couldn't run, but when we were doing the fringe.
Sabar brother, sometimes what happened, maybe in the software, maybe we have to open the software again. I shall solve that issue, inshallah.
I have a question.
Yes,
Thank you.
please.
So as you click on the save current part diagram, values from the model disappeared.
Okay, again if you click on here, view in the, it will come back again.
Okay, so how we will take this diagram
Yes,
into
very
our
easy.
output
Here
file?
one of these, suppose copy the path diagram. If you click on here and open an Word file, sorry, if you Control V or paste it here, it will come again here.
Okay, thank you so much.
Welcome. Okay, just save it, brother. Everybody, please. Sometimes some unusual things comes. It's very difficult for an instructor, for a trainer, if any unusual things, their confidence levels go down in front of my participants, in front of my trainee. Why? Sometimes it might happen. Just if these unusual things happen, what we have to do? We have to do which is coming incorrect. Then later on, when they will be as usual, then I shall go for the troubleshooting, inshallah. No use. I shall show you. No, it is not an issue, inshallah. Okay. So what will we do now? We shall create the another. Go to the CFA template again. Okay. Now we shall create the CFA welfare. Though I have done, you will do with me with me again, and I shall show. Or CFA satisfaction we can do first. CFA satisfaction. Go to the CFA template, and everybody please go to the file and save as. From the CFA template, and go to the file and go to the CFA and give a CFA satisfaction, CFA satisfaction. CFA satisfaction. Okay. Have you seen one file has been created as CFA satisfaction? Just select this CFA satisfaction. Now what will you do? Go to the list of the variables, then the list of the variables come. Now we have the 7 items of satisfaction. So what will we do? Satisfy 1, satisfy 2, drag and drop, satisfy 3, satisfy 4, satisfy 5, satisfy 6, satisfy 7. Once you have done drag and drop of these 7 items, just close this one and just rename it. Rename, so give a name of the latent variable, that is satisfaction, satisfaction, satisfaction. Okay, just close it. Then everybody, have you done until here? Now go to the plugins and name unobserved variables. Okay, it is created. So what will we do now? We will go to the calculate estimates. Click on there, everybody please. Are you following me? Everybody?
Yes,
we are.
Okay, mashallah. Just click on there. It is highlighted, right?
Okay. Yes.
This is the
said,
output
yes.
view that we can observe the result. Ensure that you are observing the standardized estimates. Okay, now here the chi-square should be in between 100 to 200, but it is okay, chi-square, but df is 14, but the difference, if you divide this 185 by 14, this value should be less than relative. This is called relative chi-square. This should be less than 5. In our case it is more than 5, so we have an issue. The p value is showing 0.000, it's okay. However, GFI is less than 0.9, AGFI less than 0.9, CFI less than 0.9, IFI is less than 9, it should be less than higher than or equal to 0.9. So CFI, TLI, NFI, okay, all of these are less than 0.9, and RAMC is less than, it should be less than 0.08. However, in our case of satisfaction, it is higher than 0.856. So we have the issue in, but one thing you have to remember, there are 3 criteria must be fulfilled from the fit indexes. Number 1, your relative chi-square, and second one is RAMC. The relative chi-square must be less than 5 for the model fit, and RAMC is very important. The RAMC should be less than 0.08, and any of them, any of the fit indexes like GFI, AGFI, CFI, IFI, NFI, TLI, among these, if any of them is equal to or higher than 0.9, then your model fit is achieving the threshold value. So your model is fit. So any of them, GFI, AGFI, CFI, NFI, TLI, from any of them is more than or equal to 0.9, and RAMC is less than 0.08, and relative chi-square is less than 5, then your model is fit. And second is we will observe So none of our criterias are fulfilling in our case of satisfaction. None of the criteria of model fit is fulfilling. So another one is that is the factor loading. In our case, as I told you already that for our factor loading, it must be more than 0.5, and it should be less than 1, and none of them should be negative values. But in our case, we are observing that satisfaction 6 and satisfy 7, these two items is less than 0.5. What should we do now? We have to delete it, right, brother?
So I have a question that what does it mean by that Ramsey is 0.85 or TLI is 752? What does it mean by that score?
Okay, these are the different criteria set by different authors, and all of this has a full name, and these are the requirement for fit indexes. Suppose in our data set, it must fulfill the GFI, AGFI, CFI, IFI. Different calculation are there, statistical calculation. Okay, so these are the fit indexes requirements. If you go to in depth, you can read some books. There a lot of explanations are given there, so you can enrich your knowledge by reading those books, brother. But in our case of our study results, so we just, if we just observe these results, and what the results is coming, if we satisfy that one, it is enough for us. Those who are not the statistician, those who are specialized in statistics and going for in depth, you can go all of this in detail. So for earlier I read it and I memorized it, but since a long time, last 6 months, I did not provide any training. Many things I forget. What is the meaning of GFI, GFI, how they have calculated. So you can read it, and you can enrich your knowledge. What does it mean? But these are the criteria need to fulfill for your model fit. Okay, brother.
Okay, sir. Thanks a lot.
Okay. So, brother, if you these two items we need to delete. How can we delete it? If we for deleting it, this is the output view we are observing now. In the left side, if you click on there, then you will be able to do any modification of your model. So, what will we do? We take the erase object, this one, and delete these two items, this one and this one. Okay. Now what will we do now? Again we will run our model. Calculate estimates. Please click on calculate estimates. So see, as per the factor loading is concerned, all of this factor loading is higher than 0.5, and none of them is 1. All are the factor loading is less than 1, and none of them are negative. So fulfilling the factor loading criteria. However, if we check to our model fit indexes, none of the model fit indexes fulfilling the criteria. So what can we do now? What would be our decision now? Anybody have any good idea? How can we solve this issue?
Maybe we should go back to the modification indices and look at the.
Yes, mashallah. Yes, then modification indexes. Yes, thank you very much. We have to go to the modification index. If you go click on here, view text, we will get our output view or view. So there we will find in the modification indexes based on certain criteria. We might have to delete some items, one or more than one items, or if we make the covariance, maybe our model can get fit. So everybody please just click on here, this one just beside left side of the save icons, say view text, this one, just click on here. If you click on here, single click, see AMOS output, just click this one. See, it is showing. Everybody got this view text? Please mute your mic. Okay. Everybody got this view text?
Yes.
Okay,
Yes, sir.
Yes.
yeah, okay.
Yes.
So we shall go to the one of the options here is modification index. Click on there. So here you got the modification indexes 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is showing here. So what will we do? Here we will observe which items has the problem. If it is the modification, which one has the highest modification index, so that we can we have to take decision that this item has the problem. So if we calculate that one based on the number of frequency as well as high modification index, suppose E3 and E4, it is the modification index is showing 75, it is the highest one, right? And 3 with 6 it is 7.26, it is 3 with 7 it is 6, and 4 with 5 it is 55, 4 with 6 it is 17, and 4 with 7 20, and 6 with 7 it is 21. So which one has the highest modification index? Suppose if we calculate the 3 E3, that is E3 75 plus 7 plus 6 plus, so this is 75 plus 7 82 and 6 88, right? So E3 is 88 modification index, and E4 here 75 and 55. See, 75 and 55 it is huge, and plus 17 it is huge, plus 20. So E4 is having the highest modification index than any other sharing the modification index than the E3, E5 or E6 or E7. So what we have to do, which have the which one has the highest modification index? That is E4, right? Everybody agreed on this?
Yes, we
Because it
agree.
is huge number, it is sharing 75, 55, 17, 20. So what we can do, we can delete this E4. E4 is representing satisfy 4, right? Right, brother?
Oh, I can,
Yes, yes, yes.
Yes. So what we
sir,
yes, yes, please, brother.
instead of deleting, since the factor loadings are all okay, why can't we vary it with E5 if possible?
Yeah, so that you compare the matching,
Okay,
the
brother.
matching terms. Yeah, the error term.
Though it is low factor loading, but it is fresh. It is these items not have any collinearity with other items, but though might be the satisfy 1 or satisfy 5 or satisfy 4, they are having the highest factor loading, high factor loading, then the satisfy 3 3, okay, but it might have the collinearity issue. Here in this case, due to the collinearity issue,
Okay.
that's why we need to delete the E4, right? So how to delete it?
Okay.
We need to go to the view in the output. Here just click on the left side and take the erase objects and delete this satisfy 4. If we delete the satisfy 4, one thing, did you note that our boss 1 is gone from our, if we run it, it will not run, we can say, just for our showing you, if we run it, it will not run. See, calculate, go to the calculate estimates. So, see, the output view is not coming. Okay. If we put here the 1, if we put here 1 parameter, if you, then it will run. Have you given the parameter 1?
Yes.
Then you calculate estimates again, it will run, inshallah. Yes, it is run. So, the red color is showing okay. Have you seen?
Good to go.
Huh?
So Alhamdulillah, the result is perfect.
The model is okay now.
Yeah. See, after deleting the most communal item, see, our model is fit and our factor loading is also okay. So, however, let's check, suppose we delete that item which is low factor loading, what is happen? Okay, for our experiment, just I am going to show you. That was the item number 4, right, brother?
Hello, excuse me.
Yes.
Yes, so it's item number 4.
Yeah.
Hello.
Yes, please.
Yes, you are saying that we deleted the items with low factor loading.
Factor
But
loading.
when we look at that item 4 that we deleted, it actually I think it has 0.65, and we have item 4. No, is it item 4 also that has a 0.61. So I think I want to go by the submission of the last speaker that suggested that we should have covariate E3, I think E3E for the one with highest modification indices, which is around 75 point something, instead of deleting the items completely. Because when we covariate it, definitely it will improve the fit indices. And at this level of CFA now, I believe before we got to this point, there must have been a kind of exploratory factor analysis conducted on these items to actually, scrutinize the items, those that are above a certain benchmark, and those that did not. So coming to CFA, and the essence of modification indices is to covariate and also to improve the fit indices. Thank you very much.
Yes. So, let's check if we improve, if we include and delete this one, just run this one. See, if we delete this one, the low factor loading, here it is, see, when we delete this one, satisfy for our fit indexes was 100% okay. If we delete the low, based on the low factor loading, what is happening there? So, this one, the low factor loading, right? Yes, lowest one is satisfy 3, right? Satisfy 3. Okay. Yes, mute your mic, brother. Okay. If we check it, we calculate again. See the results. It is how all nothing of the fit indexes is complying. Yes. Okay. So, based on our which one has the communality more covariance. So, that based on that and recommendation from the fit indexes which has the highest modification index, we have to delete that one. So, in our case, so what will we do? We will delete satisfy, this one is satisfy 3, right? We have to keep the satisfy 3. Okay, now all the fit indexes are improved. Relative chi-square less than 5, GFI, AGFI, TLI, LFI, IFI, they all are more than or equal to 0.9, and Ramsey is less than 0.08. So now our factor loading is okay, our fit indexes is okay. Now we shall calculate our construct reliability and the AVE, average variance extracted. We have a
I
formula.
want to add something.
Yes, please.
Okay. So in case of wages, we were facing some issue. I have rechecked at my end. If you change the place of 1, then the result can be displayed. So
Yes, yes,
please, it is requested to try once again.
yeah. So one must be there in your model. If while it is disappearing after deleting the items, you have to put 1 in any indicators. So
So I
one
was
must be,
talking about the issue we were facing in case of wages.
don't talk about that one. I shall come later on.
Okay.
Inshallah, that problem will be solved. Once you are habituated it, initially, then ultimately, okay, I can in different way I can try again. Maybe you can solve by yourself if we do in another cases. And you
Sir.
are,
You're already
yeah.
mentioning about the solution.
What the solution you are talking about?
If you change the place of 1,
Sister,
please open
please,
your
we will
sheet.
come. We will come there, sister.
Okay.
Now
Okay.
we are in satisfaction. Then we will yeah, take some attempts to resolve our issue in related with the ways, inshallah. So come to the satisfaction here. So what is the convergent? We have to calculate the convergent validity and the construct reliability. We have some here calculation formula for calculating the AVE, summation of delta lambda square divided by n. N means indicators, and this is the value of lambda square. This is the value of lambda. Here factor loading is called the lambda, and error terms is called the lambda square. So how can we calculate this? We calculate this 0.78. Everybody please calculate 0.78 plus use your mobile, 0.78 plus 0.83, all of this
1.61.
0.83 0.83 plus 0.38 plus 0.32 equal to 2.31 divided by 4 number of items, right, divided by 4 equal to 0.577. 0.5775. Yes,
75.
yes, it is more than 0.5. That is called AVE. How to calculate this? I have shown you. Okay. If you just please, everybody, please cautious about your mic. Okay. Satisfaction. Okay. See, all of these I have discussed in your slide very in detail, so you will not have any issue, inshallah. So, how to create the model and how to run it, how to delete it, how to take the decision, everything I have talked about. So, now I shall show you the how to calculate the AVE and construct reliability. Okay, see, AVE equal to summation of delta square divided by n. Okay, so summation of delta square is 0.78, 0.83, 0.32 plus 38 divided by 4 is a 0.58, 0.577 something, that's why it is 0.58. So, this is how we calculate the AVE. This is called the convergent validity. Convergent validity is determined by factor loading as well as the AVE. It should be more than 0.5 or equal to 0.5. So, how to calculate the construct reliability? So, we have another formula, summation of delta square. If you summation of delta square, construct reliability equal to summation of delta lambda square and divided by summation of lambda square plus summation of delta. What is summation of delta? I show you what is 1 minus error terms, that is delta square. Here in the beginning I have in wage welfare I have shown there. Okay, here. Okay, so CR equal to summation of lambda whole square and summation of lambda whole square. Here plus summation of delta. So, what is delta? That is called the measurement error equal to 1 minus lambda square. Okay, how to calculate this? See, in the case of ways where I have shown, I shall come that again, but however there how to calculate this? This is called the lambda value of lambda 0.61, 0.81. Lambda means the factor loading into whole square, and the whole square it is coming 3.68. If you add all of these, it will be 3.68 equal to in bracket whole square, then 1 minus 38, that is the lambda square value, 1 minus 0.65, this is the lambda square value, this is the values is coming for delta. So, lambda square plus delta, summation of delta equal to this one. If you divide this one plus divided by this one plus this one, the result will come this one. So, this is how we calculate the construct reliability. However, this is the manual calculation. For doing the manual calculation for getting the AVE and construct reliability. However, if you go to the folder that I have given you, I have made a formula, same formula I put into the Excel sheet. If you just put your factor loading there, then your value of AVE and construct reliability will come automatically. If you go to the folder that I have given to you, that is the calculation of AVE and CR, for making it easy for you, I have made it for you. Just open that one, everybody.